Hey, hi. Thanks once again for joining us on our continued session. This is Go-Gate Engineering Institute, as you all know, your number one engineering design solution. We prefer solutions to various aspects of structural engineering. If you continue to follow us on this page, we would always address your issues and concerns as usual based on your requests. Okay, so at Go-Gate Engineering here we analyze various aspects of structures, be it reinforced concrete structures, timber structures, offshore structures, deep water structures, floating production systems. We design jetty, maritime structures. We carry out mooring analysis. We carry out analysis of bollards. We are very good and we have extreme expertise in structural dynamics, multi-degree of freedom, single degree of freedom, blast engineering, design of structures to plastic limit states, and we are extremely very familiar with various code of practice, the Euro Code of Practice, the American Code of Practice, AISC, ACI, the British Code of Practice, as stated earlier, as well as the Australian Code of Practice. Today we've been getting requests from a number of viewers on the use of STAAD to carry out structural bar bending schedule. Okay, the use of STAAD to prepare structural bar bending schedule. Usually when you carry out an engineering design, the next thing you would want to do at the completion of your design is to prepare your structural bar bending schedule. So quickly, I would like to just show us the potential inherent in STAAD on how you can extract your bar bending schedule in STAAD. Remember, this is Go-Gate Engineering Institute. If you continue to follow us and like our page, be rest assured to always get responses to any form of questions or concerns you have as a consultant, as a professional engineer, as a project manager, a project engineer, or a student. So quickly, we want to look at this, use it as a typical example to address the issue as it relates to structural bar bending schedule. Now, this is a two-story structure that was designed. Okay, so this is the first floor structural layout. This is the first floor structural layout, and this is the roof structural layout. Okay, it's a two-story structure. We just want to zero in on our mind on how to extract the structural bar bending schedule from this design. We will take a column as a typical example and show you how to extract the structural bar bending schedule from a STAAD design results. Okay. Firstly, you would have to typically carry out your design. You have to model this entire structure. So, like I said, it's a two-story structure. All beams are 225 by 450, so that's the first floor structural layout. Okay, all columns are 225 by 225, and then all solid slab panels are 150 mm thick. Okay, the slabs are solid slabs. Recall we have several categories of slabs: solid slab, ribbed slab, waffle slabs, and then flat slabs. So when you see 225, 450, please, all units are in millimeters. So all units are in millimeters, and that's what we refer to. So how do you extract a structural bar bending schedule from a design in STAAD? So your first step is to model the structure. Okay, this is the full structure. Let's look at the full structure. So this is the full structure. Okay. That's the first floor. So that's the foundation to first floor structural layout. So if you look at that, you have to ensure that the structural member orientation, stiffness modeling, member sizes, and isotropic properties as defined are correct in line with your drawing. Okay, so your members has to be correct, sizes has to be correct, lengthwise, member sizes. So if you look at that, we have that two-way panel, two-way, that cantilever there, cantilever here, cantilever all around the perimeter of the building. we have that same consistency here. Okay, so we just want to focus our minds on how to extract a structural bar bending schedule in line with the code. Okay, so I need to be clear here that the code of practice for bar bending scheduling is in compliance with BS 866. Now, the previous code of practice was BS 4466. Okay, so 4466 was the previous code of practice, and this has been replaced by BS 8666. So we'll show you how STAAD prepares the bar bending schedule. You will need the bar bending schedule, which is going to be used on site. First of all, for extracting reinforcement shapes and sizes, weights, which are used for costing, on projects. You need to cost your project. You need to know the bar marks and how to determine the weight of the various sizes of reinforcement, be it 12, 6, 8, 16, 20, 25 mm, and the likes. So typically, you generally, define your member properties, assign them, okay, load your structure, okay. We are not concerned about that on this session. You would run your analysis. Now, as soon as you run your analysis, you go to your concrete design. Now, we want to concern ourselves on how to extract the structural bar bending schedule. Now, I will explain this using the structural bar bending schedule for the columns. Okay, for the columns. So let me go to members. So the first thing you do on the concrete designer is to define your members. Okay, so give them member numbers. How do you do that? Okay, you just right click and form member. You give all your members member numbers. So as we have it here, all our members have their respective member numbers. So I want to concern myself with the columns. The columns is what I want to concern myself with, because I want to see how we would extract the bar bending schedule for the columns. Okay, so the columns, obviously you have your main reinforcement and then your stirrups. How do we do that? Okay, so as soon as you give your members your member numbers, you move to defining your design brief. Okay, just like a design basis. When you're doing a manual analysis, all your engineering design must have a basis of design. Okay, what are the bases you are considering? What are your design assumptions and so on? So you create a design brief. So for the columns which you are concerned about, you have to be very, very particular about the code of practice. We are using BS 8110. You must be very careful about the requirements of the code in terms of the material strength, the grade of strength, the cover to reinforcement to cater for fire resistance of the structure, as well as exposure considerations. And then you put in the size of your reinforcement, as well as the other requirements in terms of the bracing and so on, the effective length properties, which is the length between the point of support brace against lateral torsional buckling, okay, and so on. So as soon as you specify the brief, or what you call the design basis for your columns, okay, you assign the basis to the respective columns. So you can see structural columns have been created, and then the columns, which is a group, have been assigned to all these column member numbers. Okay, so the structural columns has been assigned to the design basis of columns. As soon as you do this, you go to your concrete member. Now all the design groups have been created. Okay, so but we are concerned for the purpose of this lecture on the columns. So you go to structural columns, you go to design, you design your columns. Okay, as soon as you design your columns, what you're concerned about, okay, as a consultant on a project, you want to extract the bar bending schedule so that you can determine the weights and the sizes of your reinforcement, which shall be used for the purpose of costing on the project. So you just go to File, Report, take off all of this on this side, go to Scheduled Bars. Okay, scheduled bars. As soon as you go to scheduled bars, you print off your report. You could see STAAD clearly would give you the reinforcement bar bending schedules for all the columns you have specified on your model. Now let me explain one by taking just one member as an example. Let's look at this. This is member 47, for example. Member 47 has two bar mark numbers, 01 and 02. Right? First of all, the bar bending schedule is done in compliance with BS 8666. Okay? BS 86. So this is the code of practice. This is the governing Bible for the preparation of structural bar bending schedules. Capture specifications for scheduling, dimensioning, bending, and cutting of steel reinforcements. Okay, so this is the requirement. Now, you see, so he prepares the bar bending schedule. So bar mark 01, the member size is T12. Okay, you need 04, you need 4 members of that. The member length or the bar length is 3.6. Let's look at this member 47. I need to look at member 47. Let's see. That member 47. Let's see how this works. Come here. That's this member. Okay, so this member 47. Number 47 is 1, 2, 3. Is the third one there from the left. Okay, from the ground floor to the surface of the first floor. So that's 1, 2, 3. So that's member 47 there. So what's the length of that member? That's 3.6. What is it telling us as the detail? So you could see that's mark 01. You see the length is 3.6. Shape code is 00. So which of these shape code is being referred to in the code? So if I go to, okay, so you could see the shape code is 00. So it's referring to the main reinforcement. Okay, it's referring to the reinforcement that resists compressive or tensile load on the columns. So is the vertical reinforcement referring to. So see shape code 00. So STAAD tells you need 4 of those bars. So 4 number of 12 mm reinforcements. Okay, shape code 00. Then if you look at 01, so it gives you the total length. Total length is 3.6. For 02, it tells you this is the individual length of the bar. So 3.6 is the length of one of the bars. Now, for 10 mm bar, which is the stirrup, it says you need 28 numbers of the stirrup. The length, so let's look at this. This is, the shape code is 51. Let's look at the shape code. 51. Okay, so it's referring to the stirrup. So that's shape code 51. You see in shape code 51, you have A, B, you have D and C. Okay, A, B, C, A, B, C, D, E. So when you go back there, 47 STAAD gives you all the cutout lengths for A, B, C, and all that corresponding to bar mark 02. So it does this for all the members that has been defined on the drawing. So it clearly gives you the structural bar bending schedule, okay, of your structure. So I hope this is clear. I want to state here categorically that if you intend also to add additional information like the weights, okay, if you intend to add the weights on your table, it is very simple. You can extract the bar bending schedule to a Microsoft Word file or an Excel sheet like I just did. So I extracted the bar bending schedule to an Excel sheet, very simple. And then you could include a column, okay, for your weights, and then tie the weights to the member size, and then you have the weights of all your structural members, okay, for purpose of pricing and costing. Thank you very much. I believe I've been able to explain the potentials and the capacity of STAAD in preparing a structural bar bending schedule. We hope to continue to get your questions, and we will always provide a response to them. Stay on this page, follow and like us, and maintain consistency with us. Thank you very much.